Hello folks, welcome to this series of AWS services. In this video, today we are going to talk about Classic Load Balancer provided by AWS. Now Classic Load Balancer, as the name suggests, is a basic load balancer which works on a network layer and divides the traffic based on the content of network layer only. It cannot work at an application layer like your application load balancer, which means it cannot work on a layer of HTTP and HTTPS. So it just takes a request from its client. The client could be internet user or it could be another instance sending the traffic on a network layer, and on the other hand it is going to distribute the traffic across the registered instances again by using network layer. It does has all the health mechanism etc. that we talked about. To configure a classic load balancer, the main thing we need to configure is the listeners. So let's go and check it out how to create a classic load balancer. So the load balancer can be found on EC2 dashboard itself. So on the left hand side pane, you can find here load balancers. For a classic load balancers, you don't need any target group because the EC2 instances get registered directly with the classic load balancer. Target groups would be used in the application load balancer that we'll discuss in another video. So right now I don't have a load balancer. So let's go and create a load balancer. Click on this button. And now here it gives me an option to either select application load balancer or the classic load balancer or the network load balancer. Now network load balancer has been launched recently and it can replace classic load balancer in the near future. So we'll start with the classic load balancer. This is the simplest one. So go on and create it. So here I can get the name of the load balancer, call it my classic ELB. I need to select my VPC. I'll be using my default VPC. Now what kind of load balancer you want to create? Internal load balancer or internet facing load balancer? If you don't know the difference, please go to the last video and there we have explained that. So I'm going ahead for internet facing load balancer. The main thing is about our listener configuration. So here this part, load balancer protocol and load balancer port, this is about the client side of the listener. So it is going to receive the traffic on HTTP based protocol. You can also do it for TCP, HTTPS or SSL enabled protocol. Please remember that using HTTP here doesn't mean that classic load balancer works on HTTP layer. When we say classic load balancer works on a network layer, what we mean is the basis of decision of routing is done based on network layer only. So even though it is receiving the traffic on HTTP protocol, it doesn't mean it can read into the HTTP header. And since it cannot read it, it cannot take the routing decision based on the content of HTTP. This will become clear when we go about application load balancer and there when we talk about how the routing can be affected based on HTTP content. So for now here, when we say HTTP, we are just saying that it can receive the traffic on this particular port and protocol. What about instance side of it? So these two instance protocol and instance port tell you that on what protocol and port it will communicate to the instances. So these two configurations are for the client, on what protocol and port you will be communicating to the client, and this instance protocol and port is regarding the registered instance who would be the recipient of the traffic. So here it tells that what protocol and port would be used for communicating with them. Now if you want both HTTP and HTTPS or any other protocol, you can add rules here itself. I'm going to keep it simple. We'll go to the next. Now I can create a new security group. Security group is exactly similar how it works with EC2 instances. So we can create a new security group, but we have to be careful about the protocol and port that we are using. So here, since we are communicating with others using HTTP protocol, so that is something which is very necessary here. And the source should be anywhere, and here I can use HTTP, though already port number 80 is given, so it should not matter. And next. Now here, since I'm not using HTTPS, so it's just giving me a warning, I'm going to ignore it. And this is where you configure the health check. Remember when we talked about load balancers in general, we said that load balancer will keep on checking the health of the instances which are registered with it. Which means if a particular instance is down, then load balancer will no more forward traffic towards that instance. So how does it know whether a system is down or not? For that, it uses this health check mechanism. So it can use various protocols for health check mechanism. We are taking example of HTTP based mechanism, and here what it does is it pings at a particular page, makes an HTTP request. If the HTTP requests are responded properly by the instances, then it assumes that those instances are healthy. If the HTTP requests are not responded by your EC2 instances, then it will assume that instances are unhealthy. So to show in this case that your instance is healthy, you need to host a simple index.html page and you have to keep it responsive. Now when it does the health check, the load balancer has to be sure that the instance is healthy or unhealthy before marking its status as healthy or unhealthy. So to do that, it not only makes one request but multiple requests to the instances. So for example here, with these settings, it will send an HTTP request for this page and it will wait for 5 seconds to get a response. If within 5 seconds the response is not coming, then it will do a retry after this many seconds. So it will do it multiple times, and here is a threshold. So suppose if I make it 3, if 3 HTTP requests has not been responded in a row, then it will mark the instance as unhealthy. So unhealthy threshold here tells you the number of retries it does. In the same way, when the unhealthy instance is there, the load balancer still will keep on checking the health of it, and if it gets a successful response, then it makes sure that the instance is actually healthy, and for that it will do multiple tries. If all the requests are responded properly by EC2 instance, then after this many healthy thresholds, it will mark that as healthy. So this is how their health check mechanism works. You can configure all these values. Now next is registering our EC2 instances. So right now here, I don't have any instance available as of now. Otherwise, all these instances will be shown here in the list of instances. Let's check that out by creating the instances in the background. Now remember, we are creating this load balancer in Ireland region. So all my EC2 instances also has to be in the same region. So I'll just go to the EC2 dashboard, open it in new tab, and I'll launch an instance here. I'll call it web server 1. I need to make sure that it has got HTTP port and protocol enabled. Review and launch. Hope I have this keep here. And then view instances. I'm going to launch another same instance. Name it web server 2, and here you go. So now I have got 2 instances here. We are going back to our load balancers. I can go to the previous page and then come back to this page so that I can see my instances. So here you go. Now my EC2 instances are ready. So I can see all these EC2 instances here. Now though these are in the same availability zone, but they could have been in the different availability zone as well. So if I need to add those EC2 instances, I'll just need to click on that, and then if I need to enable cross-zone load balancing, I need to tick this, and then we have got another feature called enable connection draining. So connection draining is a feature which enables that in case of EC2 instance gets detached from a load balancer, then also the ongoing connections would be entertained, though the new request would not be given to that EC2 instance. So this is the time that is given for it to complete all the ongoing connections if the EC2 instance is detached from the load balancer. After this much time, it would be completely detached from the load balancer. Next, I can add tags here, or I can keep it blank. So now I can see that my classic ELB has been created. You can see all the details of that classic load balancer here in the description section. You can see what are the instances attached to it. Now you can observe that status of these is out of service. To actually make it work, it has to be in service. So right now both the instances has been declared as unhealthy. The reason is that my ELB is basically trying to access index.html on both the servers. But on my servers, neither an Apache web server is running nor a index.html is hosted. So that is why it is showing you out of service. To bring these servers in service, we need to host that small index.html web page so that ELB can ping to these pages and mark the instances as healthy. So you can store these other types as well. The health check, the configuration that we provided is here. The listener's configuration is here. Monitoring of ELB is done by CloudWatch but can be seen directly from this tab itself. Tags and then a migration. So if you want to move this particular classic load balancer to a higher version of load balancer, something like application load balancer, you can do it by launching this ELB migration wizard. So now I have 2 web servers. Both are though in the same availability zone, but they could have been in the different availability zone as well. and if you see the load balancer, they must still be as unhealthy. To make them healthy, we need to host index.html file. So these are the two servers I have attached to. So I want to show you that before creating that index.html and hosting it, it is still showing it as unhealthy. So if you go to load balancers, you go to instances, it is showing you out of service. Now these are the two servers. I'll just do sudo su and then install httpd y. The same thing I'll do here as well. I'm just installing Apache so that I can host my web page. Once it is done, I can start my service httpd start. The same thing I'll do here as well. So here I can write vim where www/html/index.html. In one server, I'm going to write syntax. So here I'm writing index.html. I've just made them be different so that we can distinguish it. So now my index.html has been hosted. We can see them individually as well. So here you go to my web server 1 and I can use the DNS name of my web server. So this is my web server 1 and we can see the page is hosted here. I'll also go to my second web server and see how does it look like. And here you go. Welcome to web server number 2. Now let's go to ELB and check out the instances. So it is still showing is out of service because it might take some time to declare it as healthy. Remember, it will have to do multiple tries before it can declare that as healthy. So here you go. Now it has made it in service, which means now it can forward the traffic to those two instances. Now if I have my internet user, which URL he should select to, or to put it differently, in my DNS setting, since there are now two web servers which are supposed to do the same work, which are these IP addresses we should put it into the DNS. So in the DNS, in the A record section, we are going to put our ELB DNS name. So that is what it is showing here. The name of the DNS should be given into the A record of the DNS settings. So rather than giving directly the address of your web server, you should put your ELB's DNS name in the DNS records, especially the A record. So whatever request will come to this DNS name, that would be served by those web servers which are attached to this particular ELB. So let's check that out. So if I use this DNS name, it is redirecting me to web server number 2. But hold on, let's refresh it. Still going to web server number 2. And here you go. Just refresh and it is now going to web server number 1. With subsequent refreshes, it is actually changing the web server number here. It means that when multiple requests are going to the load balancer, the load balancer is trying to maintain the 50% of the traffic should go to one web server, the 50% it is trying to send to the next web server. That is why we are saying that in each refresh we are going to once to web server number 1 and then it's going to web server number 2. That means our ELB is working perfectly, dividing the traffic into half and giving half of the traffic to web server number 1 and half of the traffic to web server number 2. So this is how load balancer works. Now in a real case, of course, both the web servers would be very identical. So the user would not be even knowing that from which web server he is getting the response. Here, just to distinguish that from where the response is coming, I have made it web server number 1 and 2. So this is how you can host multiple web servers with the same content and put them behind an ELB, give the ELB's DNS name into the DNS setting, and then the user can just use that normal domain name and it will be redirected to only the healthy instances. And now here if I go to my instances and kill one of my instances, suppose I'm going to bring down this web server 2, and now I go to Elastic Load Balancer. If I reload this, suppose every time now it is sending the traffic to web server 1. As soon as the web server 2 goes down, my load balancer is intelligent enough to send all the requests to web server 1 only. So the end user would not even feel that a server has gone down if you have got multiple instances and multiple identical instances hosting your web content. So with this we conclude this lesson. In the next lesson we'll talk about how to use application load balancer. See you soon in the next video. Thank you for watching.